STA 2322 Data Analysis Using Statistical Packages. Lesson 6 Linear Regression and Correlation. Learning Outcomes. What is linear regression and types of regressions? Simple linear regression model. Data entry into the SPSS worksheet and commands used in regression and correlation. Interpret the SPSS output tables of regression and correlation. Linear regression. It is used when we want to predict the value of a variable based on the value of another variable. In this case, the variable we are using predict the variable's value is called the independent variable, sometimes the predictor variable. You know that. So when we think about the graphs, there are two variables. One is independent variable and the other one is dependent variable. In the linear regression, that is same. So independent variable we called as predictor variable, and the other variable is the dependent variable, that is we called as outcome variable. The variable we are wishing to predict is called the dependent variable or sometimes outcome variable. So now you have to familiar with these terms. Independent variable we name as predictor variable. The outcome that means dependent variable, outcome variable, or sometimes it is called response variable. Dependent variable is also referred to y, dependent or response, and plotted on vertical axis ordinate of a graph. So you know that y-axis we are taking for vertical side. And the predictor variable or variables are also referred to x, independent, prognostic or explanatory variables, and plotted on vertical axis ordinate of a graph. So you need to familiar with these terms. Independent variable also called prognostic or explanatory variable. So this is plotted on vertical axis of a graph. There are two types of linear regression. The two types are simple linear regression and multiple linear regression. So simple linear regression, tells you the amount of variance accounted for by one variable in predicting another variable. In simple linear regression, you can see only one independent variable and one dependent variable. In multiple linear regression, you can see many two or more independent variables and one dependent variable. So if we are thinking about simple linear regression, you can see one dependent variables and one independent variable. So this is dependent variable and this one is independent variable. This is independent variable and this one is the dependent variable. But in multiple linear regression, you can see one dependent variable and many independent variables. Beta 2, beta 3. So this is again dependent variable and those are independent variables, right? There are so what x1, x2 up to xn are independent variables, and these are the coefficients of the beta 1 beta 3 up to beta n are the coefficient of the variables, and beta naught is a constant. So it means in the simple linear regression it is involved with one independent variable, but in the multiple linear regression there are many independent variable and one dependent variable. Now we will consider simple linear regression. This technique may be the most commonly used statistical procedure because almost all companies and government institutions forecast variables such as product demand, interest rates, inflation rates, price of raw materials and labor cost. So this can be used to the prediction. So linear regression you can use for do prediction. I think you have idea about the regression because you learn these things in your first or second semester in the lesson, I think, introduction to statistics. That is bit about, and you have to learn more in next sessions called that there is another subject, regression analysis. So now we are going to consider only about how we can analyze, how we can interpret the data using the SPSS in linear regression. We will consider an example. A real estate agent wants to more accurately predict the selling price of houses. She believes that the following variables affects to the price of a house: size of the house, number of bedrooms, frontage of the lot, condition and location. Assumptions. So following assumptions must be made in a simple linear regression. So you have to remember that there are some assumptions need to be when we are going to conduct the simple linear regression. Those assumptions are: first one is the relationship between the predictor variable and response variable is linear in nature. So it means if we are doing assumption means you have to check this before conduct the before apply the simple linear regression using the SPSS. First you have to check the linearity of the predictor variable and the response variable. So first assumption is the relationship between the predictor variable and the response variable is linear in nature. If you look at a scatter plot of a data and the data seem to be moving in a straight line, that's a good condition that data are linear. So it means you can draw a scatter plot and see whether the relationship between predictor variable and outcome variable is linear or not. Therefore we have to perform the scatter plot before the simple linear regression. So first before conducting the simple linear regression you have to perform a scatter plot. The second one is dependent variable is normally distributed. So it means you have to check the normality of the dependent variables. I think we discussed how to check the normality of the data. There are three ways, so you can use any method you like and check the normality of the dependent variable. So you can check the normal distribution with the QQ plot, or the other test also you can use. For each population denoted by the values of the variable x, the variances of these population are equal. So you have to take the you have to assume the variances of this population are equal. Simple linear regression model or the first order linear model. So you can see this. So this is the linear correlation, right? So then here you can add the simple linear regression. Graph show two variables whose relationship can be modeled perfectly with a straight line. This equation for line is y equal a plus bx. So you know that is simply when the type y equal mx plus c. So we can write it as y equals ax plus bx, a plus bx, or so we can substitute the values for the constant a equals 7 and b equals 49.24 according to this problem. So here you can see that this is the equation. So this is the regression equation, y equals 7 plus 49 2x. So when we need to when you need to predict some value, so if we need to find the dependent variable when independent variable is 2, so what you have to do is you have to go for here and then you can take the value, right? So you know that these things you learned under ordinary level mathematics, so you can use that knowledge to predict those things. B is the gradient or the slope of the regression coefficient. This is the gradient, and A is the intercept. Intercept means where it is cut the y-axis. The intercepts of the line at y-axis regression constant. Y, a value of the outcome, that means the dependent variable, and x is the value of the predictor, it means the independent variable. So this is a example for regression line. And equation for the simple linear regression model. So this is the general equation, y equals beta naught plus beta 1x, where this one is the intercept and this one is the gradient, and this is the independent variable and this one is the dependent variable. Beta naught and beta 1 are the two parameters that wish to identify, also called coefficients of linear model. So beta naught and beta 1 is also called the coefficient of the linear model, and usually x represent the exploratory or the predictor variable, and y represents the response variable. And we use the variable x to predict a response y. Usually we use b naught and b1 to denote the point estimate of beta naught and beta 1. The simple linear regression equations can be generalized to take account of k predictors. Y equals beta naught plus beta 1 x1 plus b2 x, sorry, y equals b naught plus b1 x1 plus b2 x2 plus up to bk xk. So this is a just like a equation of, this is the equation of multiple linear regression. Several scatter plots are shown in the below. None reflect a perfect relationship. It will be useful to fit approximate linear relationship to each. So you can see this scatter plot. This is a, so if you draw an imaginary line, you can see this, there is a linear relationship between these two variables. So here also you can use the simple linear regression to analyze the data. Shows the relatively strong downward linear trend. So this one shows an upward trend. So here you can see the upward trend, while it's not as strong as the first. This one is not as strong as first, because you can, if you see the spread of these points, that is not like previous one. Here shows a very weak downward trend in the data. So here I think it is difficult to see those data. So if means sometimes we can't predict using the scatter plot. Therefore we have to use another test also to see the linearity of these variables. First order model, y equals beta naught plus beta 1x plus epsilon. So where y equals dependent variable, x equals independent variables. Beta naught, it means y, that is intercept, beta 1 is the slope of the line, epsilon is the error variable. To define the relationship between x and y, we need to know the value of the coefficient of linear model beta naught and beta 1. So to find the y, so we need to first we have to determine beta naught and beta 1. For that, however, these coefficients are population parameters which are almost always unknown. So these things are unknowns. So estimating these coefficients, so we can't find these coefficients, so we are going to estimate these coefficients. So draw a random sample from the population from interest and calculate the sample statistics. So then beta naught and beta 1 are the population parameters, so we can't find those things. So we are drawing a population and we are going to estimate those coefficients for the, according to the drawn sample. However, because beta naught and beta 1 represent the coefficient of the straight line, the estimators are based on drawing a straight line through the sample data. The following equation represents the straight line. Y hat equals beta naught plus beta 1x. Hat sign we are using for the estimators, right? Y hat is a estimator because not the exact value, so we can't find the exact value, we can estimate the value, so we are using the line symbol hat for representing the estimators. Y hat equals beta naught plus beta 1x. So this is the equation. Y hat equals beta naught b naught plus b1x. If you like, you can use beta naught plus beta 1x, doesn't matter. Y has a predicted or fitted line. Y is the intercept, and beta naught is the intercept, b1 is the slope. The line is called the least square or regression line. So this one is also called the least square regression or least squares line, or you can call this as a regression line. So the coefficient b0 and b1 are derived using the calculus, so we minimize the sum of squared deviations. So we can use these formulas to find this one. So y equals 1 to n yi minus sigma hat squares. So these are the deviations, so we need to minimize the sum of square deviation, because this is the actual value and this is the estimated value. So if these two are equal, it means these deviation are very small. And these are the equations we need to find the b1 and b0, right? The sample coefficients are determined using the following formulas. b1 you can find the covariance of xy over variance of x, right? So covariance of x we can define as sigma I equals 1 to x minus x bar times y minus y bar divided by n minus 1. So where x bar equals sigma xi over n, and the variance of x we can define as x square sx square equals sigma I equals to 1 to x xi minus x square over n minus n, where y bar equals I equals 1 to n yi over n. So it is belongs to this one, right? So all the equations are given. Now you can find the regression line. I think you did those things earlier also. However, I am going to explain how to find the regression line using manually also. Example: 10 cars between 1 and 6 years old were randomly selected from the last year's sales record from a car sale. The following data were obtained where x denotes age in years and y denotes the sale price in rupees. So these data is given. So first we try to find the equation of the regression line using the manual calculations, right? We know that so we can find y hat equals b0 plus b1 x, no? So we know that this is the predicted fitted line, and b0 is the intercept and b1 is the slope. To find those things we can find b1 from this equation, covariance of xy divided by x square x, right? So then but covariance of xy we defined as sigma I equals 1 to n xi minus x bar over times yi minus y bar over n minus 1, and the variance of x we defined as I equals 1 to n xi minus x bar squared over n minus 1, where we know that what is it, x bar equals sigma xi over n and y bar equals sigma yi over n. And so if we need to find the b1, so what is the way this equation we can use? So now we know this that what is covariance of x1, it means sigma I equals 1 to n xi minus x bar yi minus y bar over n minus 1 divide by this one. Division by this means multiplication by the reciprocal, then n minus 1 is goes to up and the other one is come to down, other term n minus 1 to n xi minus x bar square. So we can cancel these two. Then b1 we can take as sigma I equals 1 to n xi minus x bar square over, sorry, not that one, xi minus x bar times yi minus y bar over sigma I equals 1 to n xi minus x bar square. So you can directly use this equation to find b1. So to find the b1, so we have to know xi minus x bar and yi minus y bar and xi minus x bar squared, also the product of these two, right? So first we need to find xi minus x bar. Before that we have to find what is x bar. So how we can find the x bar? Sigma xi over n. So first you have to add these all, right? So here 18, right, 22, 24, 29, 29 plus 4 33, 30 38, 38 plus 3 41. Then here you can take the total as 41. So we can add these things also. If we add these things we can take this value, right? Right. So then we know that 1 2 3 4 5 there are 10 entries, right? How we can find mean? By divide by 41 divided by 10, that is 4.1. then this value divided by 10, that is come 1 2 3, it's 1,772,000, right? This is the mean of x bar is this value. So you found then x bar is this value and y bar is this value. Now x bar and y bar you knew, then you can find xi minus x bar. Xi minus x bar means you have to subtract all the terms, these terms and x bar. So what you have to do is we can find the values, no? So xi means 6 minus, now our x bar is 4.1, then it is come 1.9 for here, and we will try another one. Our second value is again 6, no? Then those things 1.9, 1.9. We'll see another one 4. It means xi is 4 minus 4.1 is our mean, that is minus 0.1, right? So you can find those the other value also. Then we have to find yi minus y bar. So what is our yi? Yi means 1,250,000, 1,250,000, and our mean is 1,772,000. So we take the difference as minus 552,000, minus 552,000, right? This one is 115. It means minus 115 means that is come as 62, no? 62,000, right? Likewise you can find the other values. Then you have to find xi minus x bar square. It means xi minus x bar. Now you found 1.9 squared. It means 1.9 multiplied by 1.9, that is 3.61. then those values are 3.61, and 0.1 multiplied by 0.1, that is 0.01. then you can fill the other values also. Then xi minus x bar times yi minus y bar means you need to multiply these two. It means 1.9 multiplied by minus right? You have to multiply these two. It means minus 552,000 multiplied by 1.9. The answer is come as 1,048,800. Sorry, I did a mistake. We need to multiply. Sorry, we will check the value again. Right, we have to multiply these two, no? 552,000 into 1.9. 522,000 into 1.9, right? So that is here minus sign is there, so minus 991,800, and so we will try another value, that is 1.9 multiplied by 622,000. 622,000, no, that is minus 1,181,800. 1,181,800. So then you can fill this table, then take the total of this one, take the total of this one, then you can substitute the values for this equation, then you can find the B1, right? So we will see the completed table, right? After completing all the rows and columns, you can see this, you can obtain this table. Then it is come the sum of this column is 30.9 and sum of this column is minus 862, sorry, minus 8,622,000, right? So then we can we use the already defined equations to find B1. What is our equation? B1 equals sigma I equals 1 to n xi minus x bar times yi minus y bar divided by sigma I equals 1 to n xi minus x bar square. So now we found this value, that is minus 8,622,000 divided by, what is this, 30.9. so B1 we can take then minus 8,062,000 divided by 30.9. then we can take minus 279,029.126 means 13. so we can write minus 279,029.13, that is B1. Now we found B1. So what is our regression line? Y hat t equals B0 plus B1x, right? So then here to find B, now we have to find B0. To find B0 we can use this equation, y bar equals B0 plus B1 x bar, right? So we can simply change this equation, y bar equals B0 plus B1 x bar. Now we know about the B1, y bar and x bar, all those values we the known values. So by using these values now we can find what is B0. so y bar is, what is our y bar? That is 1,072,000, no, 17 million, sorry, this one, no, y bar 1,072,000, yes, equals beta naught we need to find, beta 1 minus 279,029.13, then x bar is 4.1, right? So B0 equals 72 plus this value 279 29.13 multiplied by 4.1, it is come 11,1144 019.433, right, plus this amount plus it is come as right beta naught equals, so then we can add these two and take this as 96.42. This is the value, right? Now we found beta b1 and b naught, then we can write the regression equation is y hat equals b naught means 2,916,019.42 minus this one minus, no, otherwise plus 279,029.13 x. What is our x is, or if you like you can write here h, right? This is the equation of the regression line, right? This is the way of doing the manual calculation. Now we will consider how we can do this using SPSS, right? To use the hypothesis testing, what we have to do, first we have to write the null hypothesis and alternative hypothesis, right? Here we will see what is our null hypothesis and alternative hypothesis. The hypothesis for regression focus on the slope of the regression line. So the null hypothesis is the slope equals to 0, or we can write there is no slope. Then the alternative hypothesis becomes the slope is not equals to 0. And the next step is you have to enter this data into SPSS worksheet and enter the age values into variable and corresponding sales values into another variable. And first thing is you according to our assumption we have to use the relationship between these two. Thus if we have the linear relationship only, we can use the linear regression. So the relationship between the predictor and response variable in linear in nature, so we have to check it. So carry out the scatter plot. So select graphs and legacy dialogues and scatter dot. Then you can see this window. Then select simple and click define button. Then you can define y-axis and x-axis. Y-axis for the dependent variable, x-axis independent variable. So our independent variable is age and dependent variable is price. So select name price from the leftmost box by the clicking this arrow, put into the y-axis box, and price for the x-axis. Select the name age from the leftmost box by the clicking put into the x-axis box, right? So click the name of the age and drag into the x-axis box. You can use both methods. Then click the titles to enter a descriptive title for your graph. Then click OK. Now we will see how we can do these things. First we are going to check the linearity of these two graphs. So we are going to do graphs, legacy dialogues, then scatter dot. So then simple scatter, define, then x-axis. So x-axis here, y-axis for there. Then you can add the title. So any title you like you have to add, but it should be the meaningful title. I'm adding the title as car prices by age, right? Continue, then click OK. So then you can see this output. So if you carefully observe this, you can see the linear relationship between the independent variable and dependent variable, no? So it means we can apply we can do the linear regression, because this shows a linear relationship between two variables, right? This is our output. The point seems to follow a somewhat linear pattern with a negative slope. So the correlation between the negative slope, right? So next we can find the correlation, right? So if it is so sometimes I told you, know, sometimes we can't see the relationship, so then it is easy to deal with the numerical values rather than taking the graphs. So that's why we are going to see the correlation between the price and the age. So to do this, so you have to go analyze, correlate, then there are two variables, so we can use bivariate. Then this dialog box is appear, so you have to enter those variables age and price to the variables box, and press this one, and you can take into the variable box. Click Pearson as the correlation coefficient, this one, then click OK. So now we check now we will see how we can find the correlation using the SPSS, right? We know the steps: analyze, then correlate, bivariate. So then we have to take variables x and y for there, and we have to choose the correlation coefficient as Pearson. Then we can click OK. So then you take this output. So now we can interpret this output. The correlation coefficient is this one. What is it? Minus 0.968. Correlation is significant at the 0.0 level, two-tailed. So you know that if it is a minus, this is somewhat closer to -1. No, it means strongly negative correlation between these two, right? So the value of R, it means a regression coefficient, is suggests to a strong negative linear correlation between the values negative and it is close to -1. Therefore, since we see a strong negative linear relationship between age and the price, linear regression analysis can be continued, right? So first thing is you have to find out the relationship between these two. It means the regression correlation, otherwise you can't apply the linear regression. So first thing is you need to find the relationship between the independent variable and dependent variable. If it is a linear relationship only, you can continue the simple linear regression. Steps in the linear regression analysis. Now you can do the linear regression. So so these are the steps: analyze, regression, then linear, then click analyze, regression, linear, and you can see this dialog box, and you will be presented with the following dialog box. So transfer the independent variables to age into the independent box. Here you can use the independent, and the variable outcome variables into the dependent box, this one. And you can do this either drag or dropping on the using the buttons, these buttons, then click the button. Okay, this is the steps we are going to use to do the correlation analysis. Now we will follow the steps: analyze, then regression, linear. So dependent variable is y, right? Independent variable is x, right? Then we have to click OK. So then we can see the following outputs. There are 4, right? So now we consider how to analyze those outputs. There are 4 outputs: variables entered, removed, model summary, ANOVA, and coefficients. So first we consider the model summary. So you can see this one. So here you can see the R value. R means the regression one. It is so earlier also we get as 0.968, and R square, adjusted R square, and standard error of the estimate. right? So now we will consider how to interpret those data. The table provides R and R square value, and the R value is 0.968, which represent the simple correlation, therefore indicates a high degree of correlation. So this is closer to 1, right? So it means high degree of the correlation. So we can take the idea about the correlation from this R, and the same value is got from the correlation analysis. Yes, this is the same value we got from the correlation analysis, but here minus sign is removed. That is only difference. And R square value, you can see that is much of the dependent variables. Price can be explained by the independent variables age, right? That is 0.937. Keep it in your mind. If the R square value greater than 0.8, it means, right, R square value is greater than 0.8, it means the dependent variables much more explained by the independent variables. So it means if it is a good model, so R square value should be greater than 0.8. Here that is 0.937. It means it is more than 93.7%. So if it is greater than 80%, that is good. It means this is very well explained by the independent variable. So this is a very good model. In this case, yes, 93.7 can be explained, which is very large. It means this is very good model, right? So keep these things in mind when we are preparing the Word document, when we are analyzing in your analysis by your own. Remember that you have to explain those outputs one by one. What is R? What are the conclusion we can take by the R? Then what is R square? So what are the limit? What is R square should be greater than 0.8 for the good model. So in there, that value is 0.937. It means that is the dependent variable is explained by the independent variables by 93.7%. It means that is very good model. Likewise, we have to interpret those outputs, right? It is not enough to take in these outputs and copy it into the Word document and keep it as it is, right? So you can't earn the marks for that. So interpretation is that's a very important part. So you have to copy those outputs into the Word document, and you have to explain one by one how you reach to the conclusion. So then next one is the ANOVA table. This table indicates that how much regression model predicts the outcome variable significantly well, right? How do we know this? So this is the ANOVA table. So you can see regression, residual, and mean square, F, and significance value also there, right? So look at the regression row and go to the significance column. It means this value. This indicates the statistical significance of the regression model that was applied. So this shows the statistical significance of that model. So here p less than 0.00, so which is less than 0.05, indicates the overall model applied is significantly good enough to predict in the outcome variable, right? So in this significance value less than 0.05, suppose here it's come as 0.1, that is greater than, no? So here since this is 0, that is less than 0.05, right? Less than 0.05, it indicates the overall applied is significantly good enough, right? So it means this should be also less than 0.05, otherwise that is not good, right? So ANOVA table represent that one. So you have to check the significance value here. Then that value is less than 0.05, then model is good enough to predict the outcome variable, right? So if model is not good enough, I think it is useless of predicting the variables. We are regression analysis, I told you earlier also, we are using for the predict the variables. So the model is not good, so predicting variables gives the wrong answers. So first then here you can take if the model is good or not. How we can do this? You have to check the significance value, and if that is less than 0.05, it means your model is good. And the coefficient table, that is coefficient provides us information on the each predictor variable. So that is the coefficient variable. So this provides us information necessary to predict the price with age. So we can see that both constant and age contributes significantly to the model by looking the significance column p less than 0.05. That thing I explained earlier. So you can now you can take this one. So here also there is a significance value, so that is also 0.000, 0.0000. It means that is less than 0.05. It means that is a significantly good model, right? So then you can find the coefficients. That's constant. Constant means why it is that is take as what is our constant? B naught. No, B naught we can take as 2,916,000. Yes, 916,019.147. And the age, that is the our beta 1 or b1, we can take this as minus 279,029.126. So we will check these values with our manual calculation. If our manual calculation is correct, we have to take the same answers. We'll see it, right? Here we got this as 2, this value and this value. Then we check with this 91, 916 and 42. Yes, that is same, no? 42 here taken as 417 means 42. And we'll see the other one, 279,029.13. 13 is taken as 126, right? It means our calculation is correct, right? So when we can write the regression equation. Y equals, we know that y equals beta naught plus beta 1x. So according to this one, so by looking the B column, this one, beta naught and beta 1, you can find beta naught means the constant, beta 1 means the coefficient of the independent variable. So by looking the B column under the understandardized coefficient column, we can present the regression equation as price means y equals 2,916,019.42 minus 279,029.13 age mean next. This is our regression equation, right? Now so you have a clear understanding about the linear regression and type of regression. So what are the types of regression? That is simple linear regression and multiple linear regression. So now we consider about the simple linear regression model, how to calculate manually, and also how we can do this using the SPSS, right? So then data enter into the SPS worksheet and commands used in the regression and correlation. So we discussed how to do these things. Then how to interpret the SPS table output of regression and correlation. So these interpretations are very important part. So then I am explaining again and again. So first thing is, what you have to do when we are making the word file, first you have to write the null hypothesis and alternative hypothesis. The next thing is you have to do the enter the data, and you have to do the interpretation, take the outputs and copy those output into the word file. Then one by one with the theory, right? With the theory you have to explain. It means you have to write the theory. If you are considering the R square value, you have to write if R square is greater than 0.8, that is a good model. Then here R square value is 0.937. It means that is greater than 0.8. It means that dependent variables explained very good by the independent variable. So likewise you have to write the interpretation, otherwise you can't earn the marks, right? So I think now you have clear understanding about the linear regression and the correlation. So if you have any problem, you can contact me. Then thank you very much.